You're gonna have to forgive me the noise. I live next to a trenching place, and I'm probably cutting my head off here. And I'm afraid this is my normal amusing sounds. It's not too bad, except when it goes after 10 p.m. Well, it serves as a good alarm clock too. It starts out right about when I get up, around 6 or so. So that's kind of nice. Okay. Anyway, I wanted to talk about something I don't actually do, even though I work with frameworks for it, which is unit testing. I was just thinking about this because recently one of my coworkers brought up, hey, we're at 46%. That's pretty good, actually. I mean, we all know that's not what our goal is. We had a goal for the company at around 75%. But 75% isn't good enough. And, you know, this is no big shock. Somebody from test saying you need more unit tests to the developers. But here's why. So, if you get around 75%, this is why it sounds good to a developer. You've probably covered just about all of the happy path scenarios with 75%. Anything you go outside of that, you're starting to look at edge cases, etc. And hey, that's QA's job, right? Well, maybe. Maybe. But it's precisely in the definitions of those edge cases that QA is often left with a really difficult task. Now, if that behavior is fixed in the unit test so that it does not change, that'll be caught, right? So, with the 75%, the happy path case, what the developers have is they can stand there and say, you know, I know this thing I released to QA will get tested reasonably well because it's not going to just flop. I mean, it's not going to just break so bad that, you know, 80% of the tests will fail when it gets deployed to a QA environment. But on the other hand, catching those kind of tricky instances that are just in a single code base is by far easiest when you do it directly with unit testing. I mean, a manual tester can see it doesn't work. You know, I entered this number, it doesn't work. Now, if it's a data issue or whatever, that's another case where it looks like it doesn't work, but the actuality is it would work fine, there's just something broken in the back end. And those are, you know, one thing that you have to look at when you're looking at integration tests. But what QA can do that probably no one else can do before that is look to see how the full integration works and shake it down more completely under those conditions. Look at those edge cases in the unit tests and use them to derive integration tests that are beyond the level at which a developer really has a chance to do. I mean, a developer is looking, when they do their integration test, it really has to be happy path. They have to make sure, does it work? Okay. They might do a couple negative cases, but an integration test is just not where their effort should be. On the other hand, determining which of the different patterns, which of the different choices in a matrix is the highest risk is exactly what QA is trained to do. To look at a situation and say, you know, I'm worried about this kind of user with this kind of data, and I'm worried about this pairing, and I'm worried about this choice. Why? Because they stand there with that knowledge of just testing continuously and seeing how the application has worked previously under full integration. Something the developer can't have done because the developer is constantly working to produce new code. New functionality obviously has to be tested, but the regression, the integration regression that QA should have developed should be targeted not at the happy path, but at these special cases which define the integration points as they work. Sure, you can have your happy path testing, but unlike what some people like Whitaker seem to define, it shouldn't be a significant portion of your testing. To tell you the truth, the pure happy path within a single application, that, along with everything else within the single application, should almost be completely covered by the unit testing. It's the easiest and cheapest place to get it. Now let's say you go step outside that unit testing and you say, okay, but I've got multiple systems in play. Now the happy path has been tested slightly by the developers. You can't trust that. You certainly have to put a significant amount of your effort there. But you also should be looking at what are the assumptions that the developer has already documented in his unit tests about how code is going to behave, and can I make it behave differently from that? Because when you make it behave differently from that, you either have an integration bug, something they probably weren't even expecting to be fed to them from this other application, or maybe, and then that's an issue where the other application is not processing all possible inputs. They perhaps did not do their unit testing as extensively as needed be to catch these errors. But then there's another set, which is every now and then requirements aren't properly documented, expressed, understood by multiple teams. And this is where it's pure gold, because this is the thing that's the hardest to do. I mean, you can spend years and years trying to develop the exact documentation and specification for how your application is going to work, and there's still no guarantee that it's going to be understood by everyone. There's a communications flaw in the sense that human interaction, communications, stale documentation, all this is inherently untestable and unprovable. So as long as that's the case, that's where our main effort should be. That's where we're most worried, right? We look at it. What are our options? Well, one of our options is improve the documentation. Well, that's really, really expensive, especially with software that's going to change. Some of that documentation is in the unit tests. That documentation has to work, right? I mean, the build doesn't go if that documentation doesn't work. So that's where the decision making should be. Here's where your specifications are. They're in the unit tests that were written before, ideally. Why ideally? Well, not only, I mean, part of it's ideal in the sense that it can't be done, but why is it such a good thing? Well, here's why. You write those unit tests, you give them to me as a tester, as your specifications, and I know how your code's going to react. I know what I'm going to expect. I can mock out your service or your code backend, and I can run my tests up against a mocked out framework meeting your specifications, right? Imagine that. Imagine that. That way I can actually develop my automated testing, my regression, etc., absolutely in parallel with the code you're writing. And maybe, just maybe, we ought to be sitting together writing those unit tests before you write the code that's going to exercise them. In that way, you get sort of a pair programming with an understanding of what the requirements are from two different people, and a real transfer of the knowledge of what's expected to actually be happening from the developer, the QA, and likewise the other way back. I can, as a QA, bring up, hey, here, I don't understand. Do you really understand this specification? And you say, no, but obviously it's this way. And I say, no, wait a minute. It looks like it might be this way. Let's go get clarification on this. Or, will agree. Yeah, will agree. Yeah, I think that it has to be that way. I wasn't getting the obvious. Wouldn't that be a nice situation? Instead of trying to deduce how I'm going to test this when the developer doesn't even know what he's writing. All right. So that's a great argument in favor of test-first design, as long as you involve all the elements of testing in unit testing. But what is so great about getting that percentage up there? Well, again, the hardest to catch flaws are those special cases that will never happen the way the integration's set. But what if the integration fails? Yeah, we have system test, which puts things through some rigors in my organization. But I've looked at what some people do in system test, where, they're doing more than just, hey, let's pull a plug, or, they're feeding horrible, input through the electrical system at the same time as something's processing to see if they can scramble the data and break it. And to some extent, we could be doing fuzz testing. I don't believe that we are in my organization. Just to see, hey, can I make my application, if one server's not down, but malicious or just behaving so badly that it's actually violating certain trust principles that I have about that data, that we kind of know we're not checking for validity. We've trusted our server, if it gives us certain headers back, that it's not going to completely blow us away with garbage. But why? I mean, we've gotten burned on these kind of things. And not just from a security standpoint, but from normal usage. Because nobody thought of certain use cases. Well, at the unit test level, you can make damn sure that each component does exactly what it's specified to do, and if you don't know what it's supposed to do and you can think of a use case and you have no idea what the results should be, well, it's time for more specs, right? And you could just document that by writing the test and then forward that to your business or whatever and say, hey, I think the program should shut down if it receives this input. And then business could say, no, it can't shut down. And it certainly shouldn't be sending a shutdown to every, But here's the thing. Those decisions have to be made and they have to be documented. And if they aren't going to be documented through a rigorous documentation process, the Agile process has its user stories. They're not going to be rigorous enough. All you got left in Agile is your unit tests. And by making your unit tests, you create documentation that cannot get out of date and that covers, if you aim for that 95% or whatever, just about everything you as a developer can think about. You're going to miss things. There's no question. Code coverage is not the greatest measure. And even if you're not trying to get around it, you're going to miss things. But that's okay. When you miss those, QA's got tons and tons of time to be testing for these odd cases, right? They might find some of them now. They might track them down. They might look to see, hey, why are my regression tests failing sometimes but not always, right? So many times we run regression tests, I finally got it to pass. It must be okay. No. It's not okay if you finally get it to pass. It should pass 100% of the time, or there should be a reason why it fails, right? Well, we don't have time to track down every failure. So if it fails maybe a fifth of the time, it's environmental issues, it's data, it's something. We'll figure it out. Oh, that test has been failing for a month. We won't worry about it. Everything's been working. That's something I was told, actually. Oh no, business would have complained if things weren't working right. Well, what I found out later was that actually there were hundreds of things that had to be hand processed because they were failing in one application that I had been told, oh no, business would complain. Why? Because that error was just written into it and always accept it as a reasonable cost. Well, to me, that's not a reasonable cost. Sure, there are worse risks, but I want to find out why something isn't working. And if I don't have the time to do that, then I think the process maybe is producing too much code and not enough test. All right.